what you're asked to do in this problem is to rewrite what's called a radical expression. And the expression that you're asked to rewrite looks like this. And the instruction is to rewrite it as an exponential expression. In other words, we want to understand what this quantity is, not using that radical sign, but instead using an exponent. So first of all, how would you even say this expression using words?
Square root of a to the eighth.
Okay, so we're getting close there.
Something like that.
So yeah, so first of all, we want the word root in there for sure. So roots are going to be something that we study in some detail this semester. It's the root of a. A is what's underneath that root sign. So it's a root because of this symbol. We call this a radical sign. And so then the only question is, what is this weird 8 doing out in the front? And so just for vocabulary's sake, we call that number out there the index of the radical. And the thing is, most of the time in your mathematical history, when you've seen the radical sign before, you've seen it without an index in the front of it, right? And without an index in the front of it, it's what we call a, what kind of root? Yeah, that's what Joe just said, it's a square root. So without an index out in the front, we call it the square root of a. So for example, if I just write a radical sign and I put underneath it the number 25, then how do I understand what that quantity is? What is the square root of 25? 5. And why is the square root of 25 5?
5 times 5.
Yeah, because 5 times 5, or another way to write that is 5 squared, is equal to 25. And so the key here is that the square on the right-hand side of this is the same as the secret index that we don't usually write, but I'm going to write it this time, of the radical. So that number corresponds to that number. So if I ratchet that up a notch, let's start with an exponential expression this time. Let's say 3 to the power 4. If I multiply that out, that's 3 times 3 times 3 times 3. Each of those pairs of 3 is a 9, so that's really 9 times 9. So 3 to the 4th is equal to 81. How could I write that as a radical expression? With 81 underneath my radical and a 3 on the other side, what am I missing?
4 outside.
A 4 is the index of the radical. Okay? So what we would say here is we would use the same words. We just wouldn't call it a square root, because the square root, as you might expect, is a way to undo the operation of squaring. So this kind of root is meant to undo the operation of taking a 4th power. So we call it a 4th root of 81 is 3. So that's what's going on here. Right? That in the original problem, what we're doing is we're taking not a square root of a, but an 8th root of a. 8th root of a. So that's the first thing to sort of let cook in this problem. But then to actually get home, both figuratively and literally, because we're running over time, what we want to do is figure out how to understand that as an exponential expression. So how many powers of a is the same as the 8th root of a? That's what we're really asking here. How many powers of a equals the 8th root of a? So what's your first guess? A to the 8th. That's most people's first guess. It's also incorrect. For the following reason. Let's go back to the examples we have over here on the right. Because if we think that that's kind of how it works, then wouldn't we write the square root of 25 as 25 to the power 2? But in fact, what does 25 to the power 2 mean?
No.
Yeah, it's even worse than 50. 25 times 25, so it's huge, right? And that's not equal to 5, the way that we would like it to be, right? So putting a large exponent there actually takes us in the wrong direction. It takes us the direction, not in the direction we want to go, but in fact exactly the opposite of the direction that we want to go. So here's the key. What I want to do in order to unravel this mystery is I want to be able to somehow go from the equation that's on the bottom here to the equation on the top by doing the same thing to both sides of the equation. Down here I have 2 powers of 5. How many powers of 5 do I have here? What's the exponent on this 5? 1. So what I'm trying to do is turn an exponent of 2 into an exponent of 1. Likewise with this example up on the top. Here, I want to turn an exponent of 4 into an exponent of also 1. And so the question I'm asking, I guess, is what operation can I do that turns an exponent of 2 into an exponent of 1? What can I do to both sides of this equation that will make that happen? And here's how I want to think about it. I want to think about it as raising a power to a power. So I want to fill in some exponent here. Because what happens, if you remember from Monday, when you raise a power to a power? The exponents multiply. So if I put another power on the outside here, and if I do that to both sides of the equation, right? Because I can't just do it to one. But if I put some power on the outside, then those 2 powers are going to multiply together. And when I multiply them together, I know what the answer needs to be. I know the product has to be 1. So I'm asking, again, a hidden factor multiplication problem. 2 times what is equal to 1? 1/2. Exactly. So the answer to that little riddle is that to turn that exponent of 2 into an exponent of 1, what I want to do is raise both sides to the 1/2 power. But now that's given it away. That's told us that taking the square root of the number 25 is exactly the same thing as raising 25 to the 1/2 power. So what do you think would be the case for our 81 example? 3 to the 4th is equal to 81. So if I go from here to here, what would I raise both sides to turn the power of 4 into a power of 1? 1/4. So the 4th root of 81 is the same thing as 81 to the 1/4 power. Right? So how do we finish our original problem? The 8th root of a is going to be the same as a to what power? 1/8. Done. A to the power 1/8. That's all there is to it. So we call this converting between the radical form of an expression and the exponential form of that expression. And these two mean exactly the same thing. The difference being that this one is a lot easier to work with because we have a lot of rules that we know for how to work with exponents, but we don't really have many rules for how to work with radical signs, and we pretty much never will this semester. So almost always when we actually have to do stuff with radical expressions, we'll convert them into exponential expressions so that we have all the power, no pun intended, actually pun intended, all the power of the rules of exponents working at our disposal.